Hi, this video we are going to introduce the temperature sensor, and TMP is our temperature sensor, and you can toggle around and then to change the temperature. And in this simple diagram, we have two AA battery, and it's connected to power and the ground of the temperature sensor. In the middle terminal is V out, and that's connected to this multimeter. And since what happens when you change the temperature of the temperature sensor, the resistance will change correspondingly. And because that's changed, then we'll have voltage change as well. How will this be helpful? Let's take a look. If the temperature drop, you notice the voltage on the multimeter readout is lower. And when temperature is getting higher, you're going to get higher voltage. How about we connect those 5 pairs of data? Basically, if you get 5 sets, temperature and corresponding voltage, then we can create a calibration curve. And then in the future, when you have this readout from the multimeter, you can go back to the calibration curve and find corresponding temperature. Okay, so this is what we are going to do today. So for example, I will encourage you to write it down. For example, at 1 degree Celsius, my corresponding voltage is 509 millivolts. And do a few more. Talk around 14 degrees Celsius is 639. So write down those 5 sets of data, which I had already did for some of the temperature and the corresponding voltage here. And our focus on now is in Excel, we're going to create this calibration curve. In order to do that, you select those data, you select, and we can go to the scatter chart. Then we have ours, and since it's a chart, let's give some quick layout. And this is our y-axis. Our y-axis means here is what? Our voltage. And this is in unit of millivolts. And our x-axis is going to be our temperature, and that's in degree Celsius, right? And we only have one series, and this chart title you can change to voltage, or you can call it temperature sensor calibration curve. All right, then we have those corresponding dots. So this is at -2, we have 490 millivolts, and this is around 90, and this is 699. Okay, and what we are going to do next is we're going to right click that. We're going to add a trend line. And you can do different ways. You can do exponential, linear, logarithm. So here, we're going to add a linear. And once we have that, we got our linear curve. And we can format our trend line. So when you right click format trend line, and there's an option here called a display equation on the chart, and we do want to do that. And you can also display R-square value. That shows R value shows how close this equation, how good a job this equation to describe this line. If it's closer to 1, which means it's really good, and ours is very close to 1. And here we have our y equation. Then this y equation is going to be helpful. So for example, I will say find temperature if the voltage readout is 50 degrees Celsius, right? 50 I'm sorry, not the voltage. Voltage readout is, let's see, 1000 millivolts. What's going to be the temperature? How do we go ahead and do it? Because we have this equation, y indicates the voltage. So we're basically solving this equation. 1000 is equal to 9.901 times x plus 507.44, right? So you basically are solving x value. What's the temperature? We can go ahead using the Excel to do that. So we're using 1000 minus 507.44, and then this is in parentheses. We're going to divide by 9.901. Then we get our temperature. So it's going to be 49.748 degrees Celsius. All right. So hopefully you enjoy this video using the thermometer readout or temperature sensor readout. You create this temperature and voltage curve, and then you can create this equation, therefore help you to figure out the temperature, unknown temperature, if you have a voltage readout. All right, I'll see you next time. Bye.